Hello everyone. Good afternoon. I am Nikunj, your physics
Good
teacher from
afternoon, sir.
Q&A. Good afternoon. I welcome you all to the Q&A class. How are you all?
Fine, sir.
Very good. So, let's start today's lecture. Okay. But before starting the lecture, first we will see what are the prerequisites. Okay. So, first we will see what are the prerequisites. So, we are studying the chapter force and pressure. Okay. Now, first the prerequisite is pressure, sorry, force, and the second is pressure. So these are the prerequisites for today's lecture. Okay. Now, if we talk about the weightage, so from this chapter, approximately 7 to 8 marks question asked every year. This chapter is important. Okay. Now, what we're going to cover today, what we're going to study today is atmospheric pressure, then applications of atmospheric pressure, and based on this, we will solve some questions also. Okay. Is this clear?
Yes,
So
sir.
now we'll see what is atmospheric pressure. But before starting the lecture, let me give a quick recap. So first tell me what is force? What is force?
The force is a push or pull.
Very good. Push or pull. Okay. Now, can you tell me that force is due to an interaction between two bodies? Yes or no?
Yes.
Force is due to an. Okay. Very good. Now, we also studied, suppose if there is a block of mass m, and let's say I'm applying a force of 1 Newton towards right, and also I'm applying a force of 2 Newton towards right. So what is the resultant force acting on this block?
The 3 Newton towards right.
Towards right. So the resultant of this force is again 3 Newton towards right. So we can say if two or more than two forces acting in the same direction on a body, so the resultant force is the sum of all the individual forces. Yes or no?
Yes.
Very good. Now, if we see the second case, suppose again there is a block of mass m, and let's say in this case 1 Newton force is acting in right direction, 2 Newton is acting towards left. So now can you tell me the resultant?
The 1 Newton towards left.
1 Newton towards left. Very good.
Left.
Why? Because if two forces acting in opposite direction, so the resultant force will be the difference of the forces, and the resultant will be in the direction of the larger force. Yes or no?
Yes, sir.
Yes or no? Very good. Now, third case, let's say again we have a same block of mass m. Now, let's say this time applying a force of 1 Newton towards the left side, 1 Newton towards left side. Now, tell me what is the resultant?
For the block will not move and the pressure will be 0 Newton.
Akshat, tell me what is the resultant here?
So can I?
Please wait. Akshat, am I audible? Okay, Devansh.
Sir, there will be no force. The result will
So,
be 0 Newton because the force is applied from both sides equally.
yeah, if two forces acting in opposite direction and of same magnitude, then the resultant is 0 Newton. Yes or no? Okay.
Yes.
After that, we studied about types of forces. So, can you tell me the types of forces?
Yes, sir, I can tell you.
Yeah, tell me.
The contact and non-contact force.
Very good. What do you mean by contact force?
The force which comes in contact of object, the interaction of two objects which has.
Yeah, there is a physical contact between two bodies. It's called contact force, and non-contact. When force acting from
When
some
there is
distance,
a
when there's a force of interaction between some distance, so we can say there's a non-contact force. Now, types of contact force.
muscular and frictional.
Very good. Muscular and friction. Now, what is muscular force?
Sir, when we exert force to do most things like exercising, riding bicycle,
Yeah,
playing
that force
football.
applied by our muscles. Yes or no?
Yes,
Okay,
yes.
very good. Now, what is friction force?
So like when we push a ball, it moves around the ground. It is
So,
frictions with the ground.
yes, very good. So, can we say the force of friction is acting opposite to the direction of motion? Yes or no?
Yes,
Yes. So it is opposing the motion. Yes or no? When we stop pedaling any bicycle or when we switch off the engine of the car, so can we say after some distance they will stop
yes, sir.
because of the friction, because there is a contact between the tire and the road. So there is a friction force acting between them. Yes or no?
Yes, yes.
Okay, very good. Now types of non-contact force.
So gravitational force, electrostatic force, and magnetic force. Is it?
Very good. Gravitational force, electrostatic force, and magnetic force. Now what is gravitational force?
Sir, sir, can I tell you with an example?
Yes, sure.
Like when we throw a ball, it comes back to us because of gravitational force.
Yeah, because of the force of the gravity, and object has some mass. Yes or no? So gravity
Yes,
attracts that mass towards its center. Yes or no? Very good.
yes.
Now, what is electrostatic force?
Uh, Sir, when we rub a scale with the interaction of our hair, sir, it gets some electrons and protons to it. And when we take close that scale to the pieces of paper, the paper attracts the scale because of electrostatic force.
Yeah, because of the, you can say when we rub a body, charged body on uncharged body, so there's transfer of charges. Yes or no? So there is
Yes,
a force of attraction or repulsion between two charged bodies. So that is called electrostatic force. Yes or no?
yes.
Okay. Now, what is magnetic force?
Sir, magnets, if we bring a magnet close, like the refrigerator door has magnets, so it
Yeah,
will
force due to
force on
magnets. Yeah, yes or no?
magnet. Yes,
Magnet force of, and a magnet apply force on the iron bodies. Yes or no? Now force has two.
yes,
Magnet has two forces, north pole and south pole. So when suppose we have two magnets and both magnets, let's say north pole of first magnet and second uh, and north pole of the
sir,
second
they,
magnet are facing each other, so they will repel each other. Yes or no?
yes, yes,
Similarly, if south pole of first magnet faces south pole of the second magnet, they will also repel each other. But if the
yes,
north pole of the first magnet faces the south pole of the second magnet, they will attract each other. Yes or no?
yes, sir.
So this is all about the forces. Then we studied about the pressure. Now what is pressure?
So pressure is force. Like,
Pressure is force upon area. Okay. Pressure is force upon area. Yes or no?
area. Yes,
And SI unit of pressure is Pascal, and we know that 1 Pascal is 1 Newton per meter square.
yes,
Yes or no?
yes,
We also studied that pressure is exerted by liquids and gases. So we
yes, sir.
know that at a certain depth,
Yes,
that is at same horizontal level, pressure remains same. But as depth
yes.
increases, pressure also increase. Yes or no?
So like you given the example of that dam.
Yeah. That if we take a, let's say, a tube, and if we make three holes on this tube, so pressure at the bottom hole will be much higher as compared to the above holes. Yes or no?
Sir, yes,
Okay. Then we studied about pressure is exerted by gases also, and pressure exerted by gases in all the directions, because gases are in random motion. Okay, they exert pressure in all the directions. Yes or no?
Yes, sir.
Now today we will see about atmospheric pressure. So first thing is that air is all around us. Yes or no? In fact,
Yes.
from we can say that above the surface of the earth, let's say up to 300 km, we have atmosphere from the surface of the earth. Okay, so the layer of air above the earth is called atmosphere, and the pressure exerted by this air is known as atmospheric pressure. The pressure exerted by this air is known as atmospheric pressure. Clear?
Yes. Sir, I have also listened that if atmospheric pressure comes in one direction, it can destroy anything.
Please come again.
Sir, I have listened that if the atmospheric pressure comes in one direction, it can destroy everything, anything which comes in the way of.
But your voice is not clear. I'm not getting a point actually.
So am
Tell
I
me, tell me.
audible?
Yes, yes, you're audible.
Sir, wait, wait a second. A call is coming.
Okay.
Sir,
Yes,
hello?
tell me, beta.
Sir, I have listened that if atmospheric pressure comes in a single direction, it can destroy anything.
Yeah, atmospheric pressure is approximately equals to 10 to the power 5 Pascal. Means 10 to the power 5 Newton per meter square. That means if we take area of 1 meter square, then the force is 10 to the power 5 Newton. That much amount of force. But why don't we feel atmospheric pressure? Because inside our body,
Because
yes, yes, tell me.
because it comes from all direction. I think.
No, because inside our body there is a blood. Yes or no? Blood flow in
Yes,
veins. Yes or no?
yes,
So there is a blood pressure, and blood pressure is slightly more than the atmospheric pressure, because of which it balances the outside, and because of which the outside and the inside pressure get balanced. Yes or no? Inside our body there is a
yes,
pressure because of the blood. Yes or no? So there is a blood pressure, and
yes,
outside there is a atmospheric pressure, and blood pressure is slightly more than the atmospheric pressure. Okay, and listen,
okay,
atmospheric pressure is due to the weight of the air present in the atmosphere above us. Okay, so at sea level, pressure is approximately 10 to the power 5 Pascal. And as we go up, let's say onto the mountains, so suppose a person is standing at a sea level. Okay, so this is the air above this person, and suppose there's a person on the mountain. So can we say the air above this person which is on the mountain is less as compared to the person which is at the sea level? Yes or no?
yes,
Yes or no?
yes,
Okay. So here at sea level, pressure is what? 10 to the power 5 Pascal. But the person which is standing on the mountain, pressure is lower than the 10 to the power 5 Pascal. Okay. But inside our body, we are balanced with the atmospheric pressure. Yes or no? So that's why
yes,
on the mountains sometimes nose got burst, and blood comes out from the nose. Why? Because
yes, sir. In
so
aeroplane, it happens also.
yeah, because if you on the airplane, so airplane is at much higher height as compared to the ground. Yes or no?
Yes,
So air above the airplane is less as compared to the person which is standing on the ground. So in airplane, atmospheric pressure that is exerting on body is less than 10 to the power 5 Pascal. But inside our body there is a blood pressure which is approximately equal to the atmospheric pressure. So what will happen at a higher height, at a greater distance from the sea level, the inside pressure becomes larger than the outside pressure. So there is a flow of liquid from high pressure to the low pressure. That's why
Yes,
sometimes,
sir.
yeah, at higher altitudes, what will happen? Nose burst and
Sir,
blood
the
will flow out of
nose
the.
sometimes bleed.
Yes or no? Are you getting my point or not?
Yes, sir.
Is this clear?
Yes.
Any doubt?
No.
Okay. So again, atmospheric pressure also acts in all the direction. Atmospheric pressure also acts in all the direction, like we studied that liquid exert pressure in all the direction. So atmospheric pressure is also acts in all the directions. Okay, is this clear?
Yes.
Okay, but the question come in our mind that how large or small is the atmospheric pressure? So atmospheric pressure is the force of gravity on air in a column of unit area. Okay, means you can also feel by let's consider an example. Suppose you have a bottle, you have a plastic water bottle, okay, which is available in the market easily everywhere. So suppose you take out the water from the bottle and place that bottle in the room or anywhere you want. Okay, so you see that shape of the bottle is maintained. When you open the cap and close the cap, the shape of the bottle is maintained, yes or no? But
Yes.
when you suck all the air from the bottle, what will happen? The bottle get crushed, yes or no, from all the directions.
Yes.
So that's what the atmospheric pressure is. Why initially the bottle is maintaining its shape? Because inside the bottle there is atmospheric air, outside the bottle there is also atmospheric air, so pressure is same inside and outside the bottle. But once you suck off the air which is inside the bottle, so inside the bottle pressure is less than the atmospheric pressure. And when pressure becomes less inside the bottle, what happened? Bottle get crushed, yes or no? Because of the
Yes.
atmospheric pressure. You can also take another example of rubber sucker. Okay, suppose you have a
Uh,
rubber sucker. So why a rubber sucker sticks to the glass?
because of
Be-
atmospheric pressure.
yes, because this is the outer portion of the rubber sucker. Yes or no?
Yes.
So when we press this rubber sucker, so what happens? There is a air between the inside portion of the rubber sucker and the wall. Yes or no?
Yes. Yes.
So when we press the rubber sucker on the wall, what happens? Air between the wall and the sucker comes
Get
out.
trapped.
Yes or no? So
Yes.
pressure between the wall and the sucker becomes less than the atmospheric pressure, but outside the rubber sucker the pressure is atmospheric, which is greater than the pressure between the wall and the rubber sucker. Yes or no? You can see here, as you push the rubber sucker towards the wall, what will happen? Air will push out, and as air is pushed out, the pressure between the wall and the rubber sucker becomes less than the atmospheric pressure. But outside the rubber sucker, the pressure is acting is atmospheric. Yes or no? The
Yes.
pressure is acting atmospheric. So because of which this rubber sucker will stick there. Okay? Yes or
Yes.
no? Now you can
Yes,
also
sir.
understand here. Suppose area of my head is 15 into 15 centimeter. Area of my head is 15 into 15 centimeter. Now what is 15 into 15? It is equals to 225 centimeter square. Yes or no?
Yes.
Now we also know that 1 centimeter is equals to 1 by 100 meter. Yes or no?
Yes.
So can we say that 1 centimeter square is equals to 1 by 100 into 1 by 100 meter square?
Yes.
Yes or no?
Yes, sir. We can.
So this is equals to 1 by 10,000 meter square.
Yes.
So in 1 centimeter square, we have 1 by 10,000 meter square. So in 225 centimeter square, can we say this is equals to 225 upon 10,000 meter square?
Yes, sir. We can say that.
Yes. So this is equals to 0.0225 meter square.
Yes.
If you divide 225 by 10,000, so this is equals to 0.225. Is this clear or not? Or any confusion here?
No, sir, it is clear.
Very good. Now, as I told you that pressure at sea level is 10 to the power 5 Pascal, or we can say this is equals to 10 to the power 5 Newton per meter square. Yes or no?
Yes.
Very good. Now we know that pressure is equals to force upon area.
It-
Can we write force is equals to pressure into area by cross
Yes.
multiplying?
Yes, sir. We can write.
Okay, now we calculate the value of force for this much amount of area. We know the pressure is 10 to the power 5. Yes or no?
Yes.
Into area, which is 0.0225. Tell me the value of this multiplication.
Okay. So
So this
is
is
it
equals
towards
to
is it 2250?
yes 2250 Newton. Yes or no?
Yes.
Okay, so you can see here the force due to air in a column of height of the atmosphere, and if area is 15 centimeter into 15 centimeter, is nearly equal to the force of gravity on an object of mass 225 kg. If you take, suppose you take a glass whose area is 15 centimeter into 15 centimeter, so the force acting, okay, because of the atmospheric pressure, because of the atmospheric air, is approximately equals to 2250 Newton, which is equal to the mass 225 Newton. You know the relation between mass and weight. We know that W is equals to mg. Yes or no?
Yes. Yes.
Where G is approximately equals to 10 for calculation, but it is equals to 9.8. So if mass is 225, so 225 into 10 becomes 2250 Newton. Yes or no?
Yes, sir.
Any doubt here?
Yeah. No.
So pressure of atmosphere on your head, you can feel this, but we can't, okay? Because pressure inside our body is equal to the pressure outside.
Outside.
Any doubt till here?
No.
Okay. Now we'll see the application of atmospheric pressure in everyday life. So the first one is drinking straw. So the drinking straw works on the existence of atmospheric pressure. How? Suppose there is a glass, okay, and there is an inside soft drink, and we want to suck this soft drink with the help of this straw. So as we suck, so air inside this straw, or you can say the pressure inside the straw or air inside the straw becomes less. Yes or no? So there is
Yes.
a decrease in pressure inside the straw. We can say the pressure inside the straw is less than atmospheric. Yes or no?
Yes.
And here outside atmospheric pressure is acting. So there is a flow of fluid from high pressure to low pressure.
No.
Outside the pressure is atmospheric, and inside, that is inside the straw, pressure is less than the atmospheric. So that's how drinking straw works. Is this clear?
Yes.
Okay. Now we'll see next example, which is syringe. So again, syringe works on the principle of atmospheric pressure, on the existence of atmospheric pressure. How?
Yes.
Suppose we have a syringe and there is a piston. So when we pull up the piston, what happens? The pressure inside this cylinder decreases. Okay. Why? Because if area is increased, so air is dispersed in that area. Yes or no? And if air is
Yes.
dispersed in that area, so pressure is reduced than the atmospheric pressure. Yes or no? But outside pressure is again atmospheric. So there is a flow of fluid from high pressure to low pressure. Yes or no?
So can you repeat it once? I didn't get it.
I am saying if we have a syringe and when you pull up the piston, yes or no? Now when you pull up the piston, so inside a syringe there is a initially there is a air, atmospheric air, yes or no?
Yes.
So when you pull up this piston, you know now what is injection, what is syringe?
Yes. Yes.
Okay, you saw syringe,
Yes, sir.
you know how it is working.
Yes.
So there's a piston. When you pull up that piston, what happens?
The atmospheric pressure develops reduces.
Outside syringe is atmospheric pressure, but inside pressure is less than the atmospheric.
Yes.
Because of that, fluid is flowing inside the syringe.
Oh.
Okay,
Yes, sir.
now clear?
Yes.
Very good. Next is dropper. Again, dropper works on the existence of atmospheric pressure.
Yes.
Okay, suppose we have a rubber bulb here. Now, when we press this rubber bulb, what happens? The air inside the rubber bulb goes out in the form of bubble. Yes or no?
Yes.
And when you release the rubber bulb, so what happens? Inside rubber bulb pressure is less than the atmospheric, but here the pressure acting is atmospheric. So again there is a flow of liquid from high pressure to low pressure. Okay,
Yes.
everyone please fill this form. Okay,
So now,
now yeah, now the next is rubber sucker. So we already studied about rubber sucker, yes or no? That how rubber sucker works?
yes, sir.
Yes
We
or
already.
yeah. So we know that here between the rubber sucker and the wall, pressure is reduced, and outside the rubber sucker, the pressure is atmospheric. So outside pressure is more than the this pressure in between the wall and the rubber sucker. That's how rubber sucker works. Okay. And the last is your water pump. Water pump also works on the existence of atmospheric pressure. Okay. So is every application is clear? Drinking straw,
Sir,
syringe,
how
dropper, rubber.
water pump works, sir?
A better water pump work on the principle of atmospheric pressure because when water pumps starts, so basically there are several mechanism there. Okay, there is a pump. Okay, there is a engine. Okay, there is a compressor. So don't get into this. You will get confused. Just know that water pumps works on the principle of atmospheric pressure. Okay, what is the work of water pump? To flow, to take the water from one level to the another level.
Yes.
Yes or no?
Yes, sir.
So when there is a difference in pressure, so water will flow from high pressure to low pressure. Yes or no?
Yes, sir.
Okay, very good. Now tell me, when we press the bulb of a dropper with its nozzle capped in water, air in the dropper is seen to escape in the form of bubbles. So once we release the pressure on the bulb, water gets filled in the dropper. The rise of water in the dropper is due to
Atmospheric.
very good atmospheric pressure. Is this clear?
Yes, sir.
Next, fill in the blanks. To draw water from a well, we have to
Pull.
pull. Very good. A charged body attract or repel?
Attracts towards.
Attracts. Very good. To move a loaded trolley, we have to
Pull it.
push it. We will push now.
Oh. No, I thought that we are pulling them.
Okay, no issue. Next, the north pole of a magnet attract or repel the north pole of another magnet.
Repel. Repel.
Very good. Very good. Okay. Next, this is your homework. Okay. This question is your homework.
Sir, can I
Next,
take the screenshot?
yes,
Can I take the screenshot?
yes, yes.
Okay, so done.
Next, the pressure of 10 kilopascal is acting on the area of 0.3. The force acting on the area will be
Force equals.
now what is pressure? Pressure is Force upon area. So what is force? Force is pressure
Sir,
into
is it
area.
8? Sir,
Okay.
is it
So
8?
okay,
3000
let me
Newton?
solve. Let me solve. 10 kilopascal means 10 into 1000 Pascal. Yes or no? And
Yes.
area is 0.3. So 10 into 0.3 is 3. 3 into 1000 is 3000 Newton. So the correct answer is option A. Is this clear?
Yes, sir.
Very good. Okay. So now we'll conclude today's lecture. So first we studied about atmospheric pressure. So the pressure on us on all bodies due to air is atmospheric pressure. Yes or no? Then we studied
Yes.
about applications. So what are the applications? First is syringe, then rubber sucker. Yes or no?
Proper.
Straw, water pump. These all are the applications of atmospheric pressure. Okay. Now in the next
Yes, sir.
class, we will solve some questions from this chapter and then we will start the next chapter, which is friction. Okay.
Yes.
So there is a homework for you that go on the platform. Okay. Go on the platform. Okay. Click on assessment section, then click on practice, click on then custom. Okay. Select science and then select the chapter force and pressure. Select on view topics. Now here you don't have to click on the view topics. Just click on the practice. Okay. Then
Okay.
click on this practice. Okay. So practice
Okay.
at least 25 questions from this chapter. This is your homework, everyone. Okay. Okay. So any doubt?
No, sir.
Yes or no? So I hope you
Yes.
enjoy today's class.
Yes, sir.
Okay. We learned something new. Okay. So keep revising, keep practicing. We will meet in the next class. Okay. Thank you,
Yes.
everyone. Bye bye. Take care.
Bye, sir.